Dan Mulligan from Project Seed.
Thank you, President Lemons, members of the board. Superintendent Telford, glad to see you feeling better. All right. Members of the audience, good evening. And distinguished administrators from Detroit Public Schools. I'm Dan Mulligan, I'm from Project Seed, and for those of you who are aware, Project Seed is a nonprofit mathematics organization for mathematicians and scientists who started in 1963, by the way, so we celebrate 50 years next year. But we teach regular full-size classes of elementary and middle school students topics from high school and college level mathematics as a supplement to the regular math instruction. The goals are to really give students boosted confidence, work on critical thinking, problem-solving skills, and of course, student achievement. We've been around, like I said, in about 50 years. In Detroit, we came to Michigan in 1970 as a statewide program, continuously in Detroit Public Schools since the mid-80s. We have a great group of students that are here to help us demonstrate the program to you tonight. The students are from Price Elementary School, and Wendy Shirley, the principal, is in the back of the room. And we have Mrs. Campbell, the teacher, and Jennifer Pierce is the Project Seed math specialist. So we really appreciate the opportunity to show you what our program does with actual students. So I'll turn it over to Jennifer Pierce.
Good evening. Good evening. Some of the students wanted to introduce our signals, so I'm going to let Zoe go ahead. Zoe for a second. I can want to stand up and do that.
Good evening, distinguished board members, ladies and gentlemen. Here are our signals. Agree, disagree, partially agree, not sure, question, comment, supports. Agree, disagree, partially agree, not sure, question, comment, support. Agree, disagree, partially agree, not sure, question, comment, support. Thank you very much.
Ladies and gentlemen, raise your hand if you have a single-digit number, a number less than 10 that we get started with. Let's hear from Mari. 4. Everybody take that number 4, put it in your head. You guys got it? I want you to multiply it by 4. Not when you have that. Now I want you to add 4. Divide by 5. And subtract 2. Raise your hand when you have it. Everybody get your signals ready for Giselle.
2.
Show what your signals are good at. All right, we're going to take that 2. When I say equals, give me the answer. 2 times 1 is?
2.
2 times 2 is?
4.
2 times, 4 times 2 is?
8.
What is it?
8.
What's 8 times 2?
16.
And 16 times 2?
32.
Raise your hand if you think you know what base we're going to be using with these numbers. All right, let's hear from Lamar.
Times 2.
Show what your signal degree we're going to use the base of 2. Yes, read that, just read. Oh, I'm making my notes. All right, how many 2s am I going to write? How many things, Zoe?
I think 1.
Do I have 1 already? Am I going to write any more?
Yes.
Who says yes? Who says no? If you say yes, raise your hand, tell us how many am I going to write?
You're going to write 4 more.
Show what your signals if you're dead. All right, stop.
Stop.
All right, raise your hand if you know what operation we're going to be using with these numbers. What do you think, Cameron?
Multiplication.
Show these signals if we're going to be multiplying. Raise your hand if you know the other operation that is repeated multiplication. Oh, Zoe.
Dividing.
Is dividing the opposite of multiplication, or is it repeated multiplication? Say it loud.
Opposite.
Raise your hand if you remember what operation starts with E. Let's see, Torrance.
I think it's called exponentation. I can't
Oh, you are so close. Who wants to try and say it? Torrance, you got the exact letters. Let's see if anybody can say it. Let's have Mark.
Exponentiation.
Everybody say it.
Exponentiation.
Nice job, Mark. And everybody stop when I have enough E's.
Stop.
All right, raise your hand if you know what number is going to go here to make it true. All right, how about, right in front of you, Mr. Mulligan, Elijah?
16.
Show the students agree that 16 is gonna go here. You got polite disagreement from Lamar, agreement from Megan, disagreement from Cameron. Raise your hand if you think it's something else. All right,
I think it might be 2E.
give support.
2E. 8.
Show the students agree that. So I got some polite disagreement. Not sure why though. Raise your hand if you disagree and want to tell us why. Mr. Mulligan, get Torrance.
I believe it's 2 and 5 because 2 and 4 would have been 16 and 16 times 2 equals 17.
Show your students agree with that. Yeah, I agree with that. So if I put a 5 here, is this true? If this is 5, raise your hand if you know what's going to go here. What's going to go here, yard?
It's going to go there as 5. I mean 4.
Show with your signals if you agree with that. Nice. And everybody, what's going to go here?
3.
And here?
2.
And here?
1.
All right, raise your hand if you know what the next problem would be. Mr. Mulligan, will you get right in front of you, Elijah?
2E6.
And everybody, what does 2e6 equal?
64.
And what's next, everybody?
2E7.
Equals?
128.
Raise your hand if you tell us, how are you getting all these? What are you doing? Can we get Cameron up here?
We have a pattern for the E problems. We have 2E1, 2E2, 2E3, 2E4, 2E5, 2E6, and 2E7. So 2E1 equals 2, 2E2 equals 4, 2E3 equals 8, 2E4 equals 16, 2E5 equals 32, 2E6 equals 64, 2E7 equals 128. So we're all counting this by 8 and 2.
Show us your agree with that. Raise your hand if you can tell us, how did you get 8 for 2 and 3? What problem did you get that? Mr. Mulligan, want to grab up here? So,
Sure, I thought 2E3 was going to be 6, right? No?
It's not going to be 6 because if you do 2 times 2 times 2, first you do 2 times 2 equals 4, then 4 times 2 equals 8. And that's like, you're wrong because when you're just doing, you're adding, you're not doing multiplication.
Did you say I'm wrong? You sound like my wife.
show with your signals if you agree with what Zoe just said. Nice job, Zoe. All right, so raise your hand if you can tell me, what is the opposite of addition? Or the inverse operation of addition? What is it, Yard?
Subtraction.
Show with your signals if you agree with that. Show with your signals if you know what the opposite of multiplication is.
Division.
Show with your signals if you agree with that. Raise your hand if you know what the opposite of exponentiation is. You want to pick somebody, Mr. Mulligan?
Sure. Do you know what it is?
Groups.
Show with your signals if you agree with that. You got a partial agreement from Mr. Mulligan. Raise your hand if you know another one. What are you thinking, Torrance? Show with your signals if you're thinking cube roots. Interesting. Raise your hand if you want to know another inverse operation of exponentiation. Anybody got a guess what L stands for? Oh, we got one hand up, one brave soul. What do you think?
Maybe something that,
I like the vocabulary, very interesting. Raise your hand if you want to read what the inverse operation, or one of the inverse operations of exponentiation is. Want to go to Kamari?
log.
Very nice. Who can read it just as well as Kamari? All right, go for it. Noel.
Log.
Say it one more time.
Log.
Everybody say it.
Log.
Raise your hand if you want to try and read this problem right here. All right, how about over here, Zion?
Log 2, 32.
Excellent, Reed. You know what, I'm going to give you a keyword. You guys stay right there. I'm going to give you some words. All right, you ready? Follow my finger.
Log base 2 of 32 equals.
Nice job. Raise your hand if you think you know what log base 2 of 32 will equal. What do you think, Torrance? Well, hold on a second.
5.
Show on your signals if you agree that it's going to be 5. Huh, interesting. If that's true, raise your hand if you know what log base 2 of 64 will be. All right, how about Megan?
6.
Show on your signals if you agree with Megan. Interesting. If that's true, raise your hand as soon as you know what log base 2 of 512 will be. Actually, you know what? Write it down your papers. Figure out what that logarithm is. When you're done, put your pencil down so I know you're ready. This is the first time they're seeing logs, so they're doing pretty good with them. Mr. Mulligan, I see the answers that I want.
I know the answer to this one.
You know it?
Yeah, this is easy.
What is it?
This is 7.
That's exactly what I was thinking. Show your signals if you agree with that. You got agreement from Kamari, disagreement from Torrance. But it's not sure from Elijah, I appreciate that. Raise your hand if you can tell us how somebody would get 7, even if you're disagreeing with it. Torrance, can you explain that?
I believe somebody would get 7 because it's the parent of 5 and 6.
What's the logarithm here? Everybody. What do we get?
5.
Then we got what?
6.
Then what?
7.
Show on your signals that if you agree that's going to be 7. Raise your hand if you think it's something else. Want to tell us what you think it's going to be. All right, how about Lamar?
I think it will be 9.
Let's see. You got agreement from Torrance, Cameron, and Megan. Raise your hand if you can tell us, how did you get 9? I thought it was 7. I don't know who to pick. Let's see, President Lemon. Would you like to pick somebody else?
You see the names?
You can just point.
Lamar.
Ah.
Good choice.
I multiplied 2 times 2, which equals 4. Then I skipped the 1 multiplication times 2 times 2, which is 4. 4 times 4 equals 16. Times 4 equals 64. Times another 4 equals 256. Times 2 equals 512.
He lost me. You got 64 times 4, and you got what?
256.
Then what'd you do?
Multiplied 2. Got 512.
Show on your signals if that's how you did it. Raise your hand if you got a different way. Come on, that's fabulous. I want to see what some of the other classmates are thinking as well. Let's hear from Yari. What else?
I took 7. I started with number 7 and I multiplied it by 2 and I got 256. And then I multiplied that by 2 and I got 512.
You started with which number?
2 is 7.
And what is 2 7 equal?
2 7 128.
And then you did what?
Multiplied it by 2 and I got 256.
Okay.
And then I multiplied that by 2 and I got 512.
Show on your signals if you agree with that. Nice. So I got several different ways. Raise your hand if you got another way to solve it.
32 together to get 5. I don't get that.
You want to pick somebody?
Sure. Zoe.
Well, I think since 2e5 equals 32, then log 232 would equal 5 because the 2e5 equals 32.
Show on your signals if you agree with that. What do you want to say, Torrance? would you solve this one? Or how did you get 6 here, Torrance?
Because 6 is the base, well, not the base number, but 64 is equal to 26.
Show what your signals be great at. Interesting. Raise your hand if you want to read. This sentence using these 4 words, and these 4 words. How about Zaire? You ready?
Yes.
Do you remember how to read this?
Log 2 30
Okay, say base.
base log 2
Log.
log
Base.
base 2
Of.
of 32 equals 5 if and only if 2e5 equals 32.
Show what your signals be great at. Raise your hand if you want to read that exactly, this next one exactly the way he did, only this time we're going to use the symbol for if and only if. How about Cameron?
Okay.
Hold on a second, Cameron.
Okay. Log base 2 of 64 equals 6. If and only if 2e6 equals 64.
Nice job. Raise your hand if you can finish this sentence. Read this and make it true. And complete it, use our checking sentence as well. How about, let's see, how about Lewis up here?
Log base 2 of 512 equals 9 if and only if 2e9 equals 512.
Show what your signals be great at. Nice job. All right, I'm going to challenge you guys. You ready? Pick up your pencils. Write down log base 5 of 125 equals squared.
Can we ask the members of the audience to try this problem also? All right, right now, we'll take that.
All right, you guys already have it?
Yes.
That's easy. I got 1, 2, 3, 4 people have it. Give you guys a couple more seconds. Oh, wow, he's got it too. And Giselle. I don't know, Mr. Mulligan, do you think they're gonna have the same answer?
I don't know, maybe we can check with their fingers or something.
That's a good idea. All right, show what your signals if the answer that's, our logarithm answer is going to be a single digit number. Do you guys agree with that or disagree with that? Double digit, single digit, double digit. Show on your fingers what you think it's gonna be. Oh, I got a 3, I got a 5, I got a 5, I got a 5, I got a 3, I got a 3, got a 3, got a 3, got a 3, got a 3. How about audience? 3, 4. Who wants to explain their answer? Oh, hands went down. All right, Ms. Campbell, how about Giselle?
Well, I did 5 times 5, which equals 25. And then I did 25 times 5, which equals 125. So I know that there are 3 5s there. So log base 5 of 125 is 3.
Show what your signals be great then. Nice. Raise your hand if you know another way to write 5 times 5 times 5. All right, Giselle, I'm gonna let you pick somebody. And everybody, what's 5 and 3 equal? What's our argument here? What does it say? What's our numerical value? What's our base? What's our base? What's our logarithm?
3,
What's our exponent?
3,
What's our exponent here?
5,
And our logarithm?
5,
Our base?
2,
Base?
2,
Argument?
32.
What is it?
32.
And our numerical value?
32.
Nice job. Everybody put your hands up nearly this. Turn around. Hands just pat your back. There you are.